I'm the difficult one that needed my own computer because demos. So I'm Allie. I'm a software engineering instructor, so I teach other people how to code. And today I'm going to be talking about augmented reality in JavaScript. So a little bit of what we're going to be talking about. So we're going to talk about what augmented reality is, and then we're going to play with a ton of different demos. After that, we will talk about the different types of augmented reality that there are out there, look at some of my code. I wrote Snapchat's filters in 47 lines of JavaScript, so we'll be talking about that. And then we're going to talk about the future, what augmented reality will look like in a couple years. So to define augmented reality, you're taking the real world, and then you're adding something to it. You may have heard of virtual reality, and that's creating a whole entire new world in 3D. I think augmented reality is really powerful because you can take the real world and then add something to it, and that's really powerful. It can be for any sense, but the one that you see most often, at least for now, is visual. So you'll have the real world and have some visual element added to it. So I am talking about augmented reality not because it's something that I do in my day job every day, but because I like art and code, and I have a blog. And so one of my blog posts about 2 years ago was about how to build augmented reality apps in JavaScript. And it turns out that a lot of people thought that I would be interested in giving talks about it, which I am, but I am not somebody, again, who writes augmented reality apps all day. So I, at that point, didn't feel like I was an expert at it. And that is actually the reason why I'm talking about it. I was so intimidated by this idea of augmented reality. I thought that you would have to know all this math and all this wild code in order to implement it. And then I did more research, and it turns out you can just do it in JavaScript. And it's basically just DOM manipulation is my whole entire application. I think that's really, really cool. At the time, I was seeing a lot of apps coming out that were using Python or C++, and they were just command line scripts that you could run and add filters to your face based off of that. And that's cool, but you have to be a programmer probably to run those applications. You have to download them, you have to have Python running. And if you build something for the web, anybody can use it just by going to a URL. Mobile apps are cool as well, but again, you have to download something, and the development is a little bit higher barrier to entry. So JavaScript makes development accessible, and it also makes applications accessible, and that's why I wanted to use it to build an augmented reality app. So there are so many different applications for augmented reality already. Art, which is one that's really interesting to me, and I think augmented reality is going to be a really huge forefront there. There is gaming as well. You may have seen something like Pokemon Go. We'll talk about that a little bit. And then businesses are starting to use it as well. So it can be a pretty powerful thing for marketing or just trying out elements as well there. And then there's also more, too, so we'll talk about some of that. So one of the most common questions that I get asked about augmented reality is, when will we use augmented reality every day? And I know for the average person in the audience, maybe you don't use augmented reality every day. But for a different demographic, mostly teenage and girls and young women, it is something that they're using every day. And my demographic is. And so I want to talk about that and how powerful it already is. There's going to be even more of a future for it, but it's already massive. So let's look at some demos. So the first two are Snapchat and Instagram. Instagram is so culturally dominant right now, not just the app itself, but the world around it. Like, I go to events, and they have Instagram installations so that you take pictures of it and market the event for them. It's a huge piece of it, and then also people buying ads on Instagram. So that one is absolutely massive. They have in the stories, you can put on filters on your face there, and then Snapchat, who they pretty much just knocked off to do it. So Snapchat allows you to take images and put them on top of your face and alter your appearance that way. Those are kind of the original ones. A fun part of this talk is that you get to see my face a lot, which is especially fun because I'm super jet lagged, but that's fine. So one that you may have seen recently, especially on social media, is called Face App. And what it does is it takes your face and does some machine learning on it and then spits it out in different ways. So the one on the bad side, the woman one, is a tweaked version of my face. So I don't even know what they changed about it, but they made it way prettier, and it's super impressive. And then the other side is the male version of my face, apparently. So I'm glad that that didn't turn out that way for me. There's also Facetune, which is a visual editing software for your phone. And you can essentially take what people made careers off of, airbrushing people back in the day, and you can do it in a couple swipes, which is really powerful, but also kind of terrifying. You can try on makeup. So Sephora's website allows you to try on all sorts of different makeup on their website. So I don't own blue lipstick, but I was wearing some earlier today. IKEA allows you to take furniture on their app and try it out in your own living room. So you can see what a piece of furniture would look like dimension-wise in your own home using this augmented reality application. Tesla, they're using augmented reality for manufacturing. So they're using it to test out their cars before putting them out into the wild. They're also experimenting it for the dashboard on your computer, trying to have different panels on there using augmented reality as well. This is one of my favorite AR applications from 2010, so it was a while ago. Zach Lieberman is an incredible artist, and hopefully this will load. Oh no, let me try this. Sorry, it looks like I got disconnected. Oh no. There we go. Okay, well, I guess that is not working. Sorry about that. So, also museums. Museums are doing really, really cool things with augmented reality. So both for extending the artwork in their museums, but also for displaying their content in different ways. For example, walking tours. It used to be that you had like headsets and would type in numbers at different pieces of art and they would tell you about it. Now, using augmented reality, you can just walk to different places, and based off of your location, you'll hear different information about the artwork. So that's really, really incredible as well. The Louvre also made it so that you could project their artwork no matter where you were in the world. So in Los Angeles, they had a warehouse, and they converted it into the Louvre by doing projections there. So that's really cool as well. Pokemon Go, you may have played this. I didn't really, but my mom was really into it, even though she didn't know Pokemon. So that was really fun. You could capture these little animals that were out in your world, and that game was huge for a while, and there are other games like it as well now. Rock climbing. Rock climbing is one of my big hobbies, and people are using augmented reality to create climbing routes and climbing competitions, which used to be static. You used to have a route setter, and you put tape up, and that's how it usually is now as well, but they're making it so that you could have routes using augmented reality instead, which allows for much quicker and dynamic route setting, so that's really cool as well. And then it even goes beyond that. So they're using augmented reality for some medical purposes as well. So in order to increase contrast for some people who have visual impairments. So you can see the different lighting that may help some people see certain settings better. So it goes beyond this artistic and marketing world as well. So there are a couple different types of augmented reality. The first one was marker-based. So marker-based augmented reality was the very first type, and you would have something that was almost like a QR code, or this hero marker here, and you would project something based on top of that. So that was pretty limited at that time, but a lot of augmented reality is still based off of markers. So something in reality that you're adding something to. Usually your face, but there are other things as well that you may add augmented reality on top of. Marker-less augmented reality is similar, but just no markers, so you're adding something to the world without an item that you're adding it on top of, so something like Pokemon Go or something that's location-based would be marker-less augmented reality. There's projection-based augmented reality, so something like that climbing route where you're actually projecting something out into the real world using augmented reality. Superimposition based, where you have something that's being added. So this is a combination, usually with marker or markerless. So something like IKEA, where you're projecting the couches into the real world, would be superimposition based. So I want to talk about the ways that you can build augmented reality apps now. So one way that you can is through something called A-Frame and ARJS on top of it. The really cool thing about it is that you can build augmented reality apps without even using JavaScript. You can just write essentially HTML code and have augmented reality apps built out. You have to use a marker like the hero marker that I showed you before. So it's a little bit limited in that respect. Not as fancy as like the face-based augmented reality, but you can build something like that where it projects a cube on top of the hero marker and 10 lines of HTML. That's the only code you have to write. It's pretty powerful. And then I have been using TrackingJS. So TrackingJS is a computer vision library for JavaScript. And what it allows you to do is detect things in the real world, and then you can use the coordinates of that thing in the real world and build on top of it. So I did face recognition, but they also have color-based recognition or parts of your face or your hands or something along those lines. And it's pretty lightweight. It's not a massive, massive library by any means. And it's super accessible. So they've got great documentation, and it's not impossible to write by any means. You don't have to do a ton of the math yourself. And so we're going to go ahead and look at my app in my code. So I'm going to switch over now. So hopefully this works on stage, but it's giving me a flower crown, and you can see that, and it does for anybody that is on the projection. I can switch it over to bunny ears as well, and it gets my face there. And this whole application was 47 lines of JavaScript, so I'll show you that code now. So starting off with the HTML, it's pretty basic. The most difficult part of this whole project was actually stacking a canvas on top of a video element. That turned out to be a little bit tricky, but the fact that the CSS was the hardest part says a lot, I think. So again, I have a video element, which is how my video is taken from my webcam, and then I have a canvas on top of that. The canvas is where the actual filters are projected on top of. So I have those two elements there, and then my JavaScript. So at the beginning, it's just a bunch of grabbing things from the DOM that I'm going to be interacting with, and then I'm creating a new tracker for the faces on the screen, and then I'm grabbing the flower crown and the button. I'm taking the image, so the image, it's going to be an image object so that I have all the information about it. That's going to store my actual crown itself and then the bunny face as well. And then I have the X, Y, width, and height. So I have to scale those in order to make them fit better. I have the ability to change pictures. And then I have the ability to change to the flower crown and the bunny ears as well. These coordinates here are just scaling for the images. I found two random PNGs on the internet that were the flower crown and that bunny face, and so I had to edit them a little bit in order to be the proper size. And so this is just scaling them, so their X and Y coordinates and their width and height, so that by default they fit on somebody's head pretty well. That was, again, the most time for this because I was just tweaking that. But again, not a huge amount of code here. And then some more tracking code. So the first one is set initial scale. This is how big the box around your face is. So behind the scenes, TrackingJS is making a box around where your face is. And so this is saying that it's going to be, the initial scale is going to be 4. If it's 10 instead, then it's a lot bigger and the crown goes way outside my head. If it's 1, then it's a smaller crown. So that's essentially what it's doing there. The step size is how often it's going to track to see faces on the screen. So this one is 2, and so it's a pretty fast. It checks for new faces pretty frequently on that video, but you could speed it up so that it tracks even faster. It's a little bit less performant in that way, or I could slow it down so it's only looking for faces every couple seconds or so. And then the last one is how picky the model is. So there is a model going on behind the scenes so that it's doing all the stats of whether something's a face or not. It's a binary classifier. I'll talk about the algorithm a little bit later. And this is just picking how picky that model is. So if I turn this even further down, so less than 0.1, then it's going to get all these false positives and think things that are not faces are faces. So I built this code in my instructor's lounge, which has whiteboard walls, and so there were pictures on the walls everywhere. And at first, before I set this edge density, it kept thinking that all the drawings behind me were faces, and they were not. So then if I make it way more picky, then it won't see my face in some lighting like this, or backstage or something along those lines. So that's just something to play with to decide how picky you want the model to be. I'm making it track the actual video element on that page, so that's how I set that up. And then here's the actual tracking. So it's an event, listens for the tracking event. When that happens, it's going to clear my canvas that I already have there. I'm going to make it blank. Then, for every face that's in that event data, it is going to draw an image on it. So that's all that I had to do. Most of this isn't even code that's related to TrackingJS. And I have this fully working AR app. I think I reformatted it so it's 51 lines of code, but it's normally 47. Oh, I added the 3 comments, that's why. I didn't even code golf this. If I had code golfed it, anybody use code golf? So code golf is when you write code that's as few letters as possible in order to pass some code challenges. I have fun doing that, but I didn't code golf this, so I did full variable names and multiple things on lines and all that. So I could have made it less than 47 lines of code if I really wanted it to, but not a huge amount of code for a pretty cool app. So the algorithm. So TrackingJS uses the Viola Jones facial detection algorithm. Facial detection and facial recognition are 2 different things. So facial detection is face, not face. Facial recognition is whose face is it. And so this uses facial detection, so it's just a binary classifier. This is a face, this is not a face. What it looks for is that people's eyes region are further back, so it's darker than the rest of your face. And then the nose and forehead region and cheekbones are lighter because they're closer to you. And so it's looking for that, essentially. It sums up the pixel values in any rectangle and uses that pixel value of dark and lightness in order to check to see if something is a face or not. And then, yeah, so that's the Viola Jones algorithm right there. It's used by a lot of facial detection software, not just TrackingJS. So that is TrackingJS, and it has, again, a lot of other classifiers as well. So it has ones for different colors. It has things for your eyes or your nose or something along those lines if you wanted to make your filters even better. I tried to add the dog filter at some point, but that got too difficult, and the nose and eye gap was too hard to implement. So definitely would recommend using those pickier models if you were trying to do even more complicated facial filters. There are also a lot of other libraries out there as well for doing this, other JavaScript libraries. And the reason I didn't go with them is just because the documentation was worse. And so that's a big call to action for open source maintainers to make sure that your documentation is good. But what comes next? So I think augmented reality is going to be huge in the future for a lot of different purposes. I think that the artistic applications are really powerful. In Washington, D.C., where I used to live, there's this art museum called the Art Tech House, and they've had tons of augmented reality exhibits there. And so definitely a lot going on in that world. And then as far as the code goes, I think that it's going to become more and more accessible. So Mozilla is coming out with mixed reality APIs that are built straight into the browser. So you don't need to download another library or anything like that. You can build augmented reality apps and virtual reality apps straight with this browser API. In addition, there's also the face detection API. That one's implemented in some versions of Chrome, and that detects whether something is a face or not already just in JavaScript and just in the browser itself. So again, you don't have to download anything else. It's really incredible how fast this is evolving and how much is already getting built into the browser. And it's even going to go further, I think, in mobile applications as well. The thing with websites is that you're really limited by webcams, and webcams aren't necessarily the best harnesser of information in the world. And so there's definitely going to be more with mobile apps than anything else. In addition, the marketing context is going to be really interesting as well. Trying on clothes, trying furniture, trying all different sorts of things built right into your browser. So that's all so these are more resources as well. So if you're interested in reading up about any more of the heavy math side or anything like that, I've got all of these linked. My slides are online, alispit.tel/ar-javascript. They will be up online as long as history goes, essentially, unless I delete GitHub or something for some reason. So they are online. You can look through all these resources on getting started with augmented reality. There's the Viola Jones paper right there, based off of that mathematical algorithm that I was talking about that TrackingJS uses for facial detection. There's also the TrackingJS implementation of the Viola Jones algorithm, my article on using TrackingJS to make the Snapchat filters. Awesome Code Newbie episode. If you saw Saran doing Command Line Heroes earlier, she has another podcast, and it's a really, really awesome episode about getting started with augmented reality. Zach Lieberman, who is my favorite augmented reality artist, I have his Instagram linked there, and then also some of the libraries that you can use as well. And keep in touch if you want to reach out. I'll be at this event tonight and then tomorrow as well, but you can also find me online if you want to talk more about augmented reality. And thank you all so much.